All right, in this video, we are looking at applications of regression. So looking at problem 1, it says the table shows the U.S. population in millions of people at 20-year intervals from 1815 to 1975. So here's that table. It says create a scatter plot. And so we'll do that in our calculators, and I'll show you how, of the data on the grid shown. We'll just do it in our calculators. Then use a graphing calculator to determine the exponential regression equation and the value of the correlation coefficient. Okay, and so as we're doing this, in order to create a scatter plot, you're going to press Y equals, and then you're going to make sure plot 1 is selected. Okay, so in your calculator, you're going to Y equals and go up to where it says plot 1 and make sure that is selected. For you, it should turn a different color or be highlighted in some sense. And then to be able to get the correlation coefficient, you are going to press mode and then stat diagnostics on. So mode, and then scroll down to where it says stat diagnostics and make sure it's turned on. Default setting is off, so every time you reset your calculator, it's going to turn off. And so mode stat diagnostics on. That's very important. Okay, and so to get the scatter plot, let's go ahead and put this data in our table by pressing stat edit. And then to get the exponential regression equation, stat calc 0. Okay, and so stat edit, clear what's in there, clear enter, highlight L2, clear enter, and then you are going to type your X's in L1. Anytime you're dealing with years, it's easier to do years since a number. That way you're not typing in 1,815 as an X value. So I'm going to do years since 1800. So that way it's just 15, 35, 55, 75, 95, 115, 135, 155, 175. Okay, so those are going to be my X's. And then we are typing our Y's. And these are in millions, so remember that. 8.3. Okay, and so to see this graph, to see the stat, you're going to want to press graph, but your window isn't going to show it automatically. And so go to window, and you want to change your X-min to kind of match your table. So right now, yours probably says -10. We're going to want to make it 0. And then our highest X value is 175, so maybe 200 would be a good value, from 0 to 200. And then for our Y values, our lowest value is 0, change your -10 to a 0, and then for Y max, on our table, it doesn't go past 215, and so I'm going to change that 4,000 to a 215. Okay, and so what in your table, x goes from 0 to 200, and y goes from 0 and y max 200. And so, or 215. So when we press graph, we can see our points kind of like exponential. You see it kind of growing up. And so when you see that curve, it kind of screams exponential, and they also told us exponential, but that's why. A lot of students see that curve and think maybe quadratic or even maybe linear, but those aren't going to be the best for this situation. And I'll show you another way to tell what would be the best model, but for now we're going with what they told us. Okay, and so now when we press stat, calc, 0, I want you to practice storing the equation, so that way we can use it. So under store regression equation, you're going to press alpha, and then trace, and then choose 1. Okay, so alpha, trace, and then choose option 1 for y1, and then go down to calculate and press enter. And so we can see the equation. Since it's exponential, we're looking for a times b to the x. And so my a value here is 8.08. And then my b value is 1.02 to the x. And of course I'm rounding as I write this, but when the calculator stores it, when you press y equals, you'll see it keeps all the decimals. That's why that's so helpful. You want that. You don't want to round when you're typing in your equation. Okay, and then the other thing is the correlation coefficient. So that's the R value. And so here's the equation they asked for. And then for the correlation coefficient, R is 0.98. And usually we'll be working with the R squared value, and 98 rounds, we'll do 985. And usually we'll be looking at the R squared value because quadratic doesn't have an R value. And so as we're trying to pick between linear, exponential, and quadratic, we'll want to compare their R values. Okay, but for now they're asking for the correlation coefficient, which is the R, not the R squared. And so the closer you are to 1, the better. And so that R value is really close to 1, so this is a good fit. This equation is a good fit for our model. Think of it like a test score. A 98 would be really good on a test. A 100 would be perfect. So if I had 1, this would be a perfectly exponential function. But now we're just getting close. And so if I press graph now, it stored the equation, and I can see it's going through a lot of those points. Okay, we're going to skip to number 3 where it says use your function to predict the population of the United States in 1990. Well, 1990 isn't on our table, but it would be right after the 1975. And so that means the years since 1800 would be 190. Okay, and so we are going to look for where x is 190 on our table. And so when you go to second graph, you'd be scrolling a long time to get to 190. And so what you can do is press second window. And where it says table start, you can just type the 190. And then when you go back to your table, it will go right there. And so in my table, I can see when x is 190, my y value, if you click on it, you'll see more values, 370. Since our table is only keeping 1 decimal, we'll just keep 1 decimal. Okay, and so predict the population in 1990, we would say 370.5, and remember it's millions. All right, for this next example, it says a 12-ounce can of soda was put into a freezer. The table shows the volume of the soda in the can measured at different temperatures. Okay, so our X values are temperatures, and our Y value is what the soda volume would be. And so it says use a graphing calculator to create a scatter plot. Okay, and so remember, in order to do that, Y equals, and then make sure plot 1 is turned on. Okay, and so for this example, go ahead and reset your calculator so we can start from scratch. So second plus 7, 1, 2. And so our memory should be cleared. And so to get this table in our calculator, we're going to do stat, edit. Stat, edit. And then we're going to put our L1 column as our X's. Okay, so you may have noticed these values are very close, and it was very difficult to type these in. So do a double check, make sure you got them all right. So 354. Okay, and so now we want to adjust our window to be able to see the stat plot. And so looking at my X's, the lowest value is 14 and the highest value is 68. So let's go from 10 to 70. And then for our Y's, it looks like we don't go below 354.5. And so I'm going to go with 354.5 for the minimum. And then 355, it doesn't get above 356. So we'll make that our top value. So window, change -10 to 10, and then change your X max to 70. Skip down to Y min. Let's do 354.5 to 356. Okay, and then now we got to turn Y equals, make sure plot 1 is selected, and then you can press graph and see our points. Okay, and so it looks like our points are going down and then going back up. That screams quadratic. Exponential functions are always increasing or always decreasing. Same with linear. They're always increasing or always decreasing. Quadratic is the only one that reaches a minimum and starts going back up. Okay, and so it says choose a regression equation that best models the data. Sketch the graph in the coordinate plane. We don't have to sketch it, but explain why the regression best models the data. And so we're choosing quadratic because it has that U shape. It's actually called parabolic if you want to be more formal, parabolic. Okay, and so now we know we want to do stat calc 5 for quadratic to get our ax squared plus bx plus c. Okay, so stat, calc, 5, and then store. When you go to store, alpha, trace, 1. So alpha, trace, choose 1, and then enter. Okay, and so you see our r squared value is pretty close to 1, so this is a pretty good fit. Okay, and so my equation, y equals, a is 8.826, I'll keep 3 decimal places, x squared plus or minus, because b is negative, move that up here, minus 0.072x, and then plus 356.353. Okay, and so of course I rounded. Usually we'd keep 3 to write the equation, but just make sure you have your x squared and your x in the appropriate place. And when you go to y equals, you'll see it keeps every decimal. And I actually wrote the 8.86 wrong. If you look here, you see an e negative 4. So that actually means there's several zeros in front of that. And so change your a value. That means we need to move the decimal 3 places or 4 places. 1, 2, 3, 4. So we would have 3 zeros. So it's 0.0008. And then we can just do another 8. Okay, and so it says predict the volume. And so we already have our equation typed in. It says predict the volume of the soda when the temperature is 20 and 60. So remember, temperature, these are x values. And so we want to see when it's 20 and we want to see when it's 60. And so x equals 20 and we want to see x equals 60. And so you're going to do second window and change your table start each time to 20, and then you're going to change it to 60 for the next one. Okay, so if you look at your table right now, it's starting at 0. We would be scrolling for a while to get to 20, which you can, or you can do second window and type 20. Then go back to second table, and we can see that our value is 355.26, and our table is keeping 2 decimal places, and so we'll keep 2 decimal places as well. And then we will look at the 60. So second window, change that 20 to a 60, go back to table, and we get 355.919, but the 7 would round it up to a 20. And so those would be our 2 values. If you want to see the full digits, notice I'm highlighting it. That's how you can see all the digits at the bottom. Okay, and so this is measured in cubic milliliters, and so make sure you include the cubic milliliters as your units. And so you can see how this would be very difficult if this was your multiple choice test and you were asked for the 20. Both of these could be options and you really want to know the correct answer. That's why when you type your equation in, you want to make sure you type in all the digits so you're as close as possible. All right, for this next example, it has a whole paragraph of information, but we don't really need that. It says the table shows the results based on many trial runs. And so we're looking at car speed for our X and then the length of skid marks for Y. Okay, and so it's asking us to write a different regression equation for each one and decide which one's best. Okay, this is where you really want to press mode, stat diagnostics, on, because these are going to be close and we want the R squared value. Okay, each of these are going to have an r squared value. The quadratic doesn't have an r value, so that's why we have to go to r squared, because we want to be able to compare all three. Okay, and so for linear regression, we're doing stat calc 4. For quadratic, it's stat calc 5. And then for exponential, it's stat calc 0. Okay, and then to store it, we'll store this. I'm gonna switch colors. We'll do alpha trace 1 for y1. For this one, we'll store it in y2. And then for the last one, alpha trace 3 for y3. Okay, and so each one of these, we want to make sure we collect the r squared value. So first thing we want to do is turn stack diagnostics on. So every time you reset your calculator, it turns it off. So let's go ahead and reset. So second plus 7, 1, 2. And then press mode. And then scroll down to stat diagnostics. And then mine is turned on. Yours will be off. So go ahead and press on so that on is highlighted. Okay, and then you can go to stat, edit, and we can put in our table. X's go in L1, Y's go in L2. Okay, and always make sure you have the same amount of X's as Y's, otherwise you miss something. Okay, and so from there, let's do stat calc. Go over to the right, calc, option 4. And then store, we're pressing alpha, trace, 1, enter. Okay, go ahead and press enter, or go down to calculate and press enter. You have that added step for your calculators. And so we can see our regression equation for linear is 5.2x, 5.21. Let's keep 3 decimal places. 0, 7x minus 136.912. And then our r squared value is 0.97. Let's write them all because we really want to see which one's closest to 1. So 0.977879432. Again, we're looking at r squared because quadratic won't have an r value. So 0.97, that's pretty good. That's close to 1, but let's see if we can get closer. So now we're pressing stat calc 5. It should say quadrag. Go down to store regression equation, alpha, trace, and then this time choose y2. Enter. Okay, and so this is going to be harder to write. We have our quadratic equation, so y equals 0.035 x squared. And then b is 0.844x. And then c is minus 24.09, or I guess it would be 010. Okay, and then our r squared value is 0.9992404 4. So far, that's better than the linear. So let's try exponential. So stat, calc, 0, store regression equation, alpha, trace, and then choose y3. Okay, and so I can see my a times b to the x is y equals 11.677 times b 1.039 to the x. And the r squared value here is 0.9403075167. Okay, and so clearly our quadratic is the winner. And then r squared is closest to 1. Okay, and then if you wanted to look at the graph, you could adjust your window. Our x's are going from 25 to 110. So let's do 20 to 120. And then our y's are going from 20 to 490. So let's go from 10 to 500. I like a little breathing room. Okay, and so if you press the graph, you can see all of our lines or our curves, our linear quadratic, but we don't see the points. And so I need to turn plot 1 on and then press graph. And then I guess it's not going to graph it for me. Oh, I'm missing a value from my table, so 490. And then graph. Okay, so there's our points. And so you can see the red curve is going through more of the points, which is our quadratic. And so that would be another reason if you had the graph, goes through the most points. All right, for this last example, it says a group of students went door to door collecting donations for a local charity. The table displays the number of donations received for various donation amounts. Okay, so our donation amount is X, and then we got a number of donations for that amount in column Y. It says analyze the data and list 3 observations. And so it looks like the X's are going up by 1, and it looks like our Y values are decreasing. So X values, as X increases, Y decreases. And so as X increases by 1, it looks like we're subtracting 40, subtracting 40, subtracting 40, subtracting 40. And it looks like this pattern continues until we get to 0. And so we could say this is a constant rate, which means we are dealing with perfectly linear data. Okay, so it says choose a regression equation that best models the data. Explain why this best models the data. And so this is linear because we have a constant rate of -40. And so that's our slope. Okay, so without even using regression, we know our equation is -40x. And to find the y-intercept, we could just go backwards on the table to 1 and just add 40, which would give us 440. Add 40 again would give us 480, and that would be our y-intercept. So without regression, we could still get the equation, but if you want to practice, we would do stat calc 4. And so in your calculator, stat, edit, let's do second plus 712. Stat, edit, type in our x's, and then our y's. And then stat calc 4. And then we can see our A value is -40, our B value is 480. And you can see our R value is -1, R squared is 1. That means this is perfect. This is a perfect fit. All right, and we do have one more example. It says, which regression would work best for the table below? And so this is another one where we want to make sure stat diagnostics is on. Mode, stat diagnostics on. And we really just want to get the R squared value for each one. So we're going to do linear, quadratic, and exponential. And we want the R squared, because that's the only value they all have. Okay, and so remember for linear, it's stat calc 4. And then for quadratic, it is stat calc 5. And then for exponential, stat calc 0. Okay, and so going to our calculator, press mode, go down to stat diagnostics on. If you've reset your calculator, it's turned off. So make sure it's highlighted on, and then stat edit. If you still have data in your table, clear, enter, highlight L1, clear, enter. Okay, and so if you want to do years since or just do the actual values, I'll go ahead and just do the actual values. The numbers for the equation might be kind of ugly because these are really large, and so just beware of that. Okay, and then for our y values, and if you notice an obvious trend in the data, that would be easy. But here from 50 to 56 to 65, we don't have a constant rate. And so it really is good to do the R squared values. Okay, and so first I'm gonna do stat calc 4. And then I'm not gonna store it because I just want the R squared values right now. And so 0.96116333875. That's the R squared value. And then we're going to do stat calc 5 for the quadratic. And we have a 0.99725199247. And then stat calc 0 for x spread. Go down to calculate, and we have 0.994937053. Okay, and so they're all really close, but it looks like quadratic is our winner. Okay, and so our best fit equation is quadratic. And if you want the actual equation, we can do that again. Stat calc 5. And it looks like our A value is 0.402x squared minus 1600.254x. Whoa, plus, that's a really large C value, 1,593,470.202. And the reason why we usually change the x values to be year since, because if these are x's are in thousands, it's going to adjust your equation numbers. So that's why it's like that. And so r squared value is closest to 1. And again, if we were to graph all these and get a good window, we could see it goes through the most points, which is why the r squared value is so close to 1.